Laws of logs. Three important laws of logs are right here. So the first one being when you add two logs together, you're multiplying them. This rule comes from exponents. When you have like x to the a times x to the b, you add the powers and you get x to the a plus b. So you can see a relationship matches. Same thing with subtraction, right? If I have x a over x b, you get x to the a minus b. So in logs, you have two logs subtracting, then you can also write it as division. Remember, it also works the other way. If you have two logs being divided, you could write it as two logs being subtracted. And then finally, probably the most important rule, well, I'm not sure most important, but when you have log base a of b to the m, you could rewrite this m as the power in front. So it looks like that, m log b. So let's use some of these logs. Use the logarithm to write as a single log or integer. So wants to rewrite as a single log. Well, plus means multiply, so we're just going to write log of 5 times 30, which is log 15. Subtraction means division, so we're going to get log base 3 of 24 over 8, which is log base 3 of 3. Can divide for a second. 3 of 3, you notice how they're the same? That is 1. Anytime it matches, it's automatically 1 because 3 is the first power equals 3. So my answer here is just 1. And in general, that's actually almost another rule I'll write down. If you ever see this, that is 1. This one's a tricky one. We're going to use this trick a lot. So log base 2 of 5 minus 1, like how do I combine these? They're not the same base. Think of the trick we just did, right? Anytime these are the same, it equals 1. So over here, we're going to write this as log 2 of 2. There's log 2 of 2 is 1, they match. And then since it's subtraction time, we're going to divide. It's going to be log 2. Now remember when you divide, it's to be a single log, so you just put a line. Top is 5, bottom is 2. So there we go. Right, a little nicer. So it's a trick we're going to do quite a bit. Next one. Simplify by writing it as a single log or rational number. So again, we're going to write as a single log. Now this one has a number in front, so we have to move this up first before we write it as a single log. Before we combine, we have to move those up. So I get log of 7 squared minus log of 2 to the third. If we want to simplify this, log of 49 minus log of 8. And then log of 49 divided by 8. Next one, here's that rule again, right? How do I combine these two? Well, I could rewrite this as log. Now notice there's no base. When there's no base, it means it's base 10. So log of 10. Because then the base is 10 and that's 10, so it's 1 together. Bring these powers up. I get log 3 squared plus log 10 cubed. This is log 9 plus log 3 zeros, right? Anything to the 10 to a power is just how many zeros it has, so 1,000. And plus means multiply, so log of 9,000. Next one. You got log of 8 over log of 4, and you're like, what could I do? There's actually not much. What we're going to do is we're going to rewrite 8 and 4 as a power of 2. So it becomes log 2 to the third and log 2 squared. And now you can move the powers to the front. And I get 3 log 2 over 2 log 2. Logs 2 cancel. You just get 3 over 2. Okay, let's do a couple more. Same idea here, we want to combine all these. Notice that there's just a 2, so we're going to do the same trick we did before. Log n is the base, so we're going to do log n log n. So let me write this as 2 log n, minus 1/2 log n to the 4th, minus 1 log of n to the 5th. Now before I combine anything, you got to move the powers to the front. So the numbers in front, you got to make them a power, So numbers in front to a power. Right here, 4 to the 1/2 power is the same thing as saying the square root of 4, so that's 2. So we're going to get log n squared minus log n2 minus log n5. Now, when you combine it all as a single log, this is the general way you want to do it. So you want to log n and then put a line. Anything that's positive goes on top, anything that's negative goes on the bottom. So the only positive thing I have here is n squared. And I have 2 and 5 both on the bottom. It's 2 and 5. I was doing the math in my head too fast. So we get log n squared over 10. Let's answer that one. Over here, kind of like the one we did over there, we want to try to combine this a little bit more. I could write this as 5 squared, 25. That's one I could think of. 0.2 is the same thing as saying 2 over 10, which is the same thing as saying 1 over 5. So let's just rewrite it. Log 3 of 5 squared over log 3 of 1 over 5. Now you want these to be exactly the same, so I'm going to rewrite this as 5 to the negative 1 power. Then we can move these powers to the front. We get 2 log 3 of 5 over negative 1 log 3 of 5. These cancel, and you just get negative 2. Okay, let's move on. Show that this equals that. Okay, so I'm going to use this, and we're going to go, this is saying log of 3 to the negative 2 power, right? Probably should have done one step earlier, which is log of 1 over 3 squared. Move it to the top to get this, and now you just move this in front. And there we go. You show that this side equals that side. Same thing that. I'm going to show same thing here. I'm going to show that this equals this. Now in this case, let me work on this side for it first. So I'm going to use the same trick we did before. This is log without a base, so it's log base 10. So it's the same thing as saying 3 log of 10 minus log of 2. Right, so again, if it has no base, it's a base of 10. So if you want to make this a 1, it's 10, 10, which is just log of 10. There's 3 right here. We'll make it, before you combine it, make it a power. So log of 10 cubed, which is also just 1,000, minus 2. So subtract means divide, so I get log of 1,000 over 2, which is log of 500. And we have those two sides match. Next one, suppose P equals log B of 2 and Q equals log B of 3 and R equals log B of 5, right, in terms of P, Q, and R. So this is actually one that IB loves to do. So let's look at this first one here to get the idea across. I have a 6. Remember, I can only use this 2, 3, and 5. So 6 I could write as log B of 2 times 3. And then remember, multiplication logs is the same thing as saying addition. Log base 2 plus log base B of 3. And now this guy is this, and this guy is this. So I just write this as P plus Q. So that's what they mean. They want you to rewrite this so you get one of these guys, and then you replace those guys with P and Q. So it's the next one. So I have a division sign, so let's rewrite that. It's the same thing as saying subtraction, so that's logs. Like that. Now log 2 is good. I have P. Right here though, that is not a choice. I gotta rewrite this still. 9 is the same thing as saying 3 squared. So this is minus log B of 3 squared. I'll put a P already. I'll rewrite that as a P. And then here, the normal mistake most people make is they'll look at this and they'll think, oh, it's Q squared. It's not. So this is not P minus Q squared. Bad. What this is you gotta move that thing to the front. The power is the thing I mean. So you get P minus 2 log B3. And now I can rewrite this, right? This equals, why did I change colors? Equals that. So this is P minus 2Q. So P minus 2Q is here, not P minus Q squared. Very important. You have to move the power to the front before you replace it. Okay, let's try it again. So in this one, let's straight out go, okay. So this one's kind of like a little backwards. Log base 2 of P is X, log base 2 of Q is Y. It's the same idea, but it looks a little funkier. Right here, it's all about expanding this. So log 2 of P squared plus log 2 of radical Q. Now, again, it's not just log Q is Y. It's not the square root of Y. That's not what's going on here. You can rewrite this power. And I'm going to move this 2 to the front. So square root power is saying Q to the 1/2. That's what square root power is. And you can move that power to the front. I can move this to the front. I get 2 log 2 of P plus 1/2 log 2 of Q. And now this equals X, and this equals y. So 2x plus 1/2 y. The one right here, same idea. So it's going to be log 2 q3 divided by something subtract, and then we're going to skip that was what I did last time, and it's going to write r to the 1/2 now. So we know it. So we see the square root is from right 1/2 power. And now you just move the powers to the front. We're almost done. And now this equals y, and this equals z. And there we go. That's the lesson.